Part 3 is a little bit of a sneaky question, because if you're not reading it carefully enough, you might miss the fact that as well as the root 5 being introduced, the 2 has turned into a 3 as well. So that makes the question much more complicated. If it had just been a root 5, if the 2 root x had turned into 2 root 5x, then it would be a much more straightforward question. You could treat it as an x stretch, because the x has been replaced with 5x, or you could treat it as a y stretch, because you could rewrite it like this. So you could say that it's been stretched in the y direction, scale factor 5. We can't say that because the 2 has turned into a 3 as well. So how do we deal with that? Well, what we can do is we can think about what this has times by to turn into this. So if we try and write it as the the minus 2 and the root x, what else has snuck in to turn it into a 3? So in other words, what else have we times by to turn the minus 2 into a minus 3? Well, we've times by 3 over 2. Minus 2 times 3 over 2 is minus 3. And of course, we've also times by root 5 for this root 5x to be introduced. So that is the long version of this. But the reason I've written it like that is because we can hopefully now see what our function has been times by to produce this. And this is a y stretch, this is a y transformation. Because we've times the whole function, we could write it as if we've times the whole function by 3 root 5 over 2. And if we times the whole function by something, that's a y stretch. So we can now answer the question. We can say that it's a stretch in the y direction, scale factor 3 root 5 over 2.